Yeah, thanks. All right, so we were left at this point where I want to look a bit inside these two boxes just to give you a flavor of how behind the scene things are working. And the reason why I want to show you this is for the people that are a bit interested in doing their application, maybe they can find some of this idea interesting, and also because then this will motivate us to look at other design that people have went through. Okay, so let's look inside some of these boxes. So I show you transformation. It was for instance, the where transformation, where we filter out. In our example, we filter out people that are not less than the number we are trying to compute the CDF for. Now, in here, we have different components. So first, as John was pointing out before, mainly this is based on code that has already been built by other people. In particular, here we have inside the same kind of primitive, the primitive where, that is available in Link, this library for SQL-like of programs. So it's an encapsulation of this kind of primitives. And what actually the Pink implementation does is to create a new Pink wearable object that is this object that has the data and the budget and manage the tracking of the budget, and it creates a new one with a new data, mainly with the new table from which we filter out the previous element. So we take the big table, we filter out the record that are not less than, let's say, 50, and we return this query with a new agent that is updated. Now, what is this new agent? A new agent is the one responsible for the privacy budget. And the idea is, sorry, let me go here. The idea is that this new agent compute for us the information that we need to understand how much of the privacy budget we need to consume. In particular, this is a transformation, and we need to understand what is the influence of each individual on the transformed result. In this case, we have a where operation, which is a filtering operation. So we can assume that if I have an individual in the original data, I will still either have this individual or this will be filtered out. So the influence that each individual has remain almost the same. So the upper bound we can give is 1 because the influence is at most 1. Now this design I wanted to mention can in principle supported also by other model of differential privacy, because here we create a new agent that are somehow responsible of pieces of the entire data. So this could support also model like the local model of differential privacy or intermediate model. I don't think people have looked into this yet, but it's something that maybe interested people can look at in this semester. Yeah.
So when you say the local model, I mean, are you talking about sort of like local algorithms, or are you actually imagining that like I have a query that sort of, you know, the query gets dispatched to like everyone's phone and the phones like come
So no, I'm thinking more so now I was thinking just about the management of the budget and the local model. The one you suggest, the dispatching of the query and so on, is what is behind AirAvat that we will get to soon, right after this.
So when you have parallel composition, do you split it into two agents or several agents?
Yes, when you do parallel composition, you split into several agents. That's exactly the idea.
And then you sum them up.
And then you take the max
I see.
for parallel composition. while for sequential, you do the sum.
So why doesn't that cover the local model?
That was,
Because you partition the data into...
Yeah, that's what I'm saying. I mean, the way Pink is set up is to work on a global data set, but in theory, all these structures that are built in can be used also for other model. When it was proposed for the central model, but I think adapting it to more the local model would not be something too difficult because the kind of design is good.
Could you give us some intuition for why you're creating new agents instead of just sharing the same agent?
I can try to give an intuition, but this, of course, this was Frank's design, is not my design. So I think the intuition is just because by creating this chain of agents, we take care of the amount of privacy noise we need to add. And I will show you in the next slide when we will look at the aggregate. So this information here, mainly, is a kind of multiplier that tells us the influence of each individual. And it does this through different agents. But
it's all tied to the same underlying agent still. So now when I operate on this new object, the budget for the original object is getting updated.
Yeah, that's the idea. And that's why this new agent is built on the previous agent. This is exactly the idea. So create a chain of agents. Now, why is with a new instead of an update? I don't know exactly. That's Frank's design. Any other question? Now, what I want to make clear is that we are looking into this box, but this is something that the API designer does. So if we want just to use this language, we don't need to look into this. Okay? But I think it is useful here to look into that.
In particular, if you wanted to prove that this satisfies differential privacy, this is one of the pieces of code you'd have to analyze.
Yes, if you want to make sure, verify fully that this satisfies differential privacy, you need to look into this box and verify that this is correct. And this, I will come back to this because this is one of the difficult things to do.
Part of the trusted code base or something.
Exactly. Yeah.
And stability, there means sensitivity?
No, okay, here is, I didn't want to go too much in the detail, but you can think as, so the way Frank uses stability is the idea that we start with a data set and we generate a new data set, and this how much the influence of one record in the original data set has in the transformed data set. It differentiates it from sensitivity because sensitivity interprets it more in the sense of a numeric query. So when we look at aggregation, there is sensitivity, which is which is computed through stability. Let's look into that. So this is how the aggregation looks like. Is the implementation of noisy count. And again, here we have the implementation of count just in link, like before, but now we add Laplace noise. And here is where we check if we have enough budget. So before adding noise and returning the answer, we check if we have enough budget. If we don't, we throw an exception. And we add Laplace noise. Now, I want to go even further in the box, because here there is another box, this agent alert. So now I want to unfold this to show you exactly how we check for budget. So this is the unfolded code. So here is where we compute the sensitivity. So we take the scale that we have used before, and we multiply it by epsilon, assuming that we add Laplace noise according to epsilon. So the scaling is a multiplier for this sensitivity. And with this, we compute the new epsilon. Then we check if we have enough budget to account for the new epsilon. And then we add the Laplace noise accordingly to this, and we decrement the budget. Okay? So it's what you would expect. It's just that this is baked in the API, and we don't have to, if we use it, we don't have to look into this. We don't have to do this manually. Okay? And again, this is provided by the API designer. Okay? All right, so back to the big picture. We saw an example with this. We saw two examples, one using parallel composition and one using sequential composition. Now, yeah. Any question about this? Okay. So just a few other words about Pink. So in the original design, it was supporting only differential privacy, the pure definition, but it's a design that we can adapt to other definitions, like Renyi differential privacy, CDP, ZCDP, and so on. Clearly here, the idea is of focusing on programming. So we want to give a user the ability to program this kind of application. And it has been extended also with some other feature that I didn't discuss here to address graphs or a graphs application, or to address a streaming algorithm. I can give you more information if you need. Now, the other language I mentioned is this ARABAT that was a quite old project. It was from UT Austin when Vitaly Shmatikov was there. And the idea was to provide an interface like Pink, but based on the map and reduce paradigm. So is the idea that John was saying, to dispatch the query, or at least the way I interpret John's question. It was the idea of dispatching the queries to smaller and smaller part of the data, and then aggregate by reducing. Again, it focuses on programming. The management of the budget is a bit different, but the general idea is similar. Now, I'm not, I didn't see actually the code that the census is using, but as far as I know, is a combination of some differential privacy basic primitive and some map and reduce approach based on Spark, I think. So in some sense, I think this kind of approach could be useful for other applications. It's a bit a pity that was discontinued and nobody worked on this anymore, but I think it's a good approach, and I believe it should be something we should consider again.
So I was also like limited to a very small family, like much smaller than Pink, right, in terms of this.
So in the original design, yes, the main question I think that is also related to the use of sample and aggregate and other approaches is what exactly we can do with the reduce. So in some sense, it's still focused on programming, but it's more limited, yes. Because when we reduce, we need to aggregate.
And also the fact that the user has to manage the budget is sort of like arguably that was the thing that Pink was trying hardest to avoid.
Yeah, to avoid. Yeah, exactly. So that's, I think they were both quite early paper, and they were addressing two different kind of problems.
So this issue with timing attacks, isn't that also an issue that Pink has?
So so we need to distinguish, I think, two kind of timing attack. The high-level timing attack, like trying to bake in a program that just, let's say, wait 5 minutes if copy is in the database, and otherwise it gives right away the answer. And the first implementation of Pink was, the implementation of Pink is subject to this kind of attack. I think people know how to address them, but they were never addressed. I think we know how to address this kind of issue. We need a runtime that address them, but they were never addressed. And yeah, and also a rabbit. Any other question?
So in general, it's possible to build these systems that give us good assurance against side channel attacks, like timing or whatever happens?
I think a reasonable assurance, yeah. So for instance, people have looked into building a runtime system where at the order of microseconds, you don't have some side channel, in the sense that you need to make sure that you pad your operation, so every operation takes the same time and you cannot distinguish. So in principle is possible. And there is a lot of research in formal methods outside of privacy trying to address this kind of problem. It's a problem that all the security applications have, and there are some countermeasures. Of course, if we go there, we are in the setting where found the countermeasure, then there is another attack that come in, and it's difficult to really say with side channel if they are completely addressed. Any other question? Okay, so we have two languages that do differential that help us building application for differential privacy. Why do I have still time to talk? So why aren't we done? So let's try first to understand a bit what are the trade-off here for Pink and the rabbit. And I go back to the picture I presented you before, and the place I put Pink, as I said, it's difficult now to realize the 3D direction, but the idea is that is quite good in usability, is not super expressive in a way that I will explain soon, and the granularity is quite low. So you should imagine that is quite against the wall. Okay, so why I put it there? So usability, I think the burden on the programmer is quite low, in the sense that as we saw before, we can just use this primitive, which put really a low burden on the programmer, because they are very similar to the one we would use in Link or in C#. Now, the expressivity, I put it not too far on the right, because it's true that we can program with it, but in some sense we are a bit constrained by the kind of building blocks that we have, so we cannot do too subtle things with our application. So the algorithm design that we would like to do is quite constrained. Okay, mainly what we can do is composition and basic primitive. And then the granularity is because we have these black boxes behind, and we are relying on them, so we are not really proving our application correct, but we are just relying on some principle that we hope will work well. So, what are some of the issues? So, here I try to identify some issues and try to connect them to what people have done after these works. So, one of them will be the next step. So now it will be more looking into the boxes and try to understand what we can do there. Now I want to focus a bit on the fact that several aspects of the enforcement depend really on the particular implementation. So we look at inside the code and we are relying on that code. What happens if we get something wrong? So for instance, here we were computing the sensitivity, I said. But what if we have some bug that get into this? Why it is true that this is the sensitivity? How can we guarantee this? What about if the sensitivity is wrong? We are adding the wrong amount of noise, so we are not differentially private. Also, reasoning about this can be subtle. And Pink doesn't give us any formal calculus to compute the sensitivity. So how do we make sure that is the correct thing to do? Another aspect that people were a bit unsatisfied with Pink is that the privacy budget enforcement is dynamic. What do we mean by dynamic? If we go again into the box, we had this checking of the budget, and if we don't have enough budget, we do throw an exception. Now, is this bad? So I don't think it is necessarily bad. I think it's important to have some dynamic or some kind of way that is dynamic to track the budget. But I think it's important also to realize the difference between tracking the budget dynamically because we are trying to do an interactive kind of approach, so interactive queries, or dynamic because we do an analysis of our algorithm, which is dynamic. So in most cases, the algorithm can be analyzed statically, and then we can still have a dynamic consumption of the budget when we run the algorithm. So in some sense, this is a bit unsatisfactory because by relying only on dynamic guarantees, we don't give information to the user about how he can organize his privacy budget. While in theory, we would like to have a kind of planning that we can do, where we can say, okay, I have query A that cost me some amount of some epsilon 1. I have a query B that cost me epsilon B, and then I can decide which one to run and so on. So these approaches are completely dynamic and don't allow this kind of method. So people have tried to address this too, and let me present one approach on which I was also involved. I didn't put on, I put a general citation because there are many work in this direction. It was work mainly done at UPenn by the group of Benjamin Pierce. I was there for a couple of years and I keep collaborating with them. So this approach tried to address these two issues that I just mentioned. So the first one was the enforcement depend on particular implementation, and then the dynamic privacy budget. So, and how did we do this? So first, we built our new language on a semantics model based on the idea of metric spaces and non-expansive function. I don't know why I wrote non-expanding. But with the idea of having a model where we can reason really about sensitivity, and we can say this function, this program has this sensitivity. And again, it relies a bit on the specification of the user on some basic primitive, but this specification now is supported by a mathematical model that guarantees that is correct. The tool that we have doesn't do this connection, but in theory we could prove that each basic building block has the good sensitivity. And the tool that we have is implemented as a type checker instead of as a dynamic monitor, because then we can do this statically. And again, is similar to the previous one because it doesn't require reasoning about probabilities. So what is the idea here? It's this idea of having a semantic model first from which to start. And this is not a new idea. It was already in the original paper calibrating noise to sensitivities, just we made it more formal and more available to the programmer. Yes?
Is it possible to explain how you're using the word semantic in this case, or will you?
Formal, yes. So the way I use it is formal semantics, which is exactly which mean that every program has a mathematical interpretation, which is the model, the semantic model. So, sorry. Every program is interpreted in a semantic model, which is in a mathematical function describing what the program computes. So it's in the same way, if you want, that formal logic use semantics. Like when I have a formula, I have a model for it. If I can interpret this formula, when I have a formula, I can interpret it in some way in another domain that is maybe a functional domain, or maybe a truth value based domain, or a Kripke model domain, and we use it in the same way.
But the model itself, how close is it to meaningful properties? I don't know, does this line of questioning even make sense? If it doesn't, then just...
No, so the exact model we use is a model based on function, as I said, on metric spaces and on some specific function which is non-expansive. And now we can reason about this in the usual mathematical way. So we can prove properties about specific element in this model. Maybe what is a bit confusing for you is that how we connect the property we prove in the model with the program. So mainly we transfer the property from the program to the model. We interpret the program in the model, we prove the property in the model, and we transfer it back to the program.
I mean, I think for me the confusion is the property in the model to something in the real world that we might...
So, okay, but something in the real world here is a program. It's not so it's something that is also, that we can also formalize. I'm not talking about data analysis or I'm starting from a specific program. So this specific program is a piece of code that has a clear interpretation. So the interpretation is the one that when I run the program, I will see the result. Okay. So we are not trying to interpret the reality in the model. We are trying to interpret the specific program. Okay, so based on this idea, we build this language, and the idea is that it's similar to what we saw for pink, but the key idea is not anymore composition, but is more compositional analysis of the sensitivity of program. It's a slight change which give different properties. And the key property that we want is that we can formalize it so that we can say when a primitive is good to add or not. And also it blurs together the sensitivity and the stability concept that we saw in pink, because now we have only sensitivity. So also a transformation on the data will be sensitive in some sense. Okay. So let's see how we re-implement this in this language, so that I will try to give you a feeling of how this works. So mainly the implementation is exactly the same as the non-private one. So we start from an implementation that is exactly the same as the non-private one, and then we try to estimate the sensitivity at type checking time of this function, and then we add noise and we check that we add the noise in the correct way. So the kind of way the type, maybe some of you are not familiar with type checker, but let's say the way our tool work is we take this kind of program and we wonder how sensitive it is on the database, how much noise do we need to add. And to compute this, mainly the program, the type checker, will perform a program analysis trying to infer this quantity. And how it works, so as I said before, we have some basic primitives that have some sensitivity. Here I put where as a basic primitive. We can go inside where, because in some sense we have this semantics model that support our reasoning, and we can make sure that now this is the right sensitivity. And we can do the same for count, and then the type checker combine for us and say that the overall sensitivity is 1. Since we are mapping it over the buckets, so we have multiple buckets, now we need to think about this compositionally, and we need to provide to the type checker a bit of information, because the type checker is not able to directly detect this, so we need to provide the length of the data to the type checker, because this is statically determined. And so now we can compute the overall sensitivity by solving some recurrence equation that tell us that is n. Now, this is n in our model because we have a generalized sensitivity that work over all the data structure, included the data set. And then with this we can add noise. And again, the type checker propagate the information to this, and this guarantee that we are an epsilon differentially private.
So sensitivity is a property of, not of data, but of the computations that you are.
Yeah. Sensitivity, as I said, every program, so this program is interpreting a metric model based on a non-expansive function. And in particular, this is a function, and the sensitivity is a property of the function.
Okay, I'm probably just confused by the way I wrote it near the data that is transferred to this program.
Okay, so it's because we have a multiple argument function, and so I write it in this way to say that is the sensitivity on the first argument. So one of the key points here is that now we need to provide, so like before, we need to provide some primitive that we use, but also we need to provide a bit of annotation like the length of the list. Why we write n here is because So at static time, when we do our type checking, we don't have available the length of the list that we will apply this program to. So we need to generalize and introduce a variable n that say represent the length. And then we can use this information in the type checking. Any question? I know some of this type checking is not familiar to most of the audience, but I think the overall picture is that we can statically ensure now that a particular piece of code require an amount of privacy budget. So we can determine statically how much budget we would need for this query. And we could do this also in other methods, but in this case we do with this sensitivity tracking. And this idea is a kind of alternative with what we have seen with Pink, has been developed also to address adaptivity, because in this sense, the way I presented you seems very static, but then we can use the static checking inside of a runtime environment where we will discount what we use for each query from the real budget at the right moment. Any question? Okay. Then let me try to put this.
So I think maybe just this point you were just making about adaptive epsilon. So maybe I'm having a little trouble sort of visualizing. Like, it's like I write a program that's going to make decisions about which epsilon to use at various points in the middle. But when I write the program, it's like checked whether I could possibly exceed the budget.
So you can think about this in maybe in this sense. So here you can imagine that you want to implement some data analysis, let's say k different data analysis, and now this method tells you each one of them how much it will cost. In the sense of given a parameter, it will tell you how much it will cost. Now you can imagine of when to use them. You will have another program that will use them, and at that point you need to commit to a specific value of epsilon, and you will discount this from the general budget. So in some sense, this epsilon here is a parameter, it's not a concrete epsilon. So we are just analyzing how much parametrically this function consumes.
But I guess I'm asking maybe even like a more basic question. Like when I write the program and compile it, like will I compile it and it'll say like, sorry, I can't guarantee that you stay in the budget? Or will it like run and sometimes it runs and tells me that I exceeded the budget and it had to cut me off? Or will it like,
I see.
Once I compile, will it like, is it guaranteed to run?
So once you compile, so it depends if you want to use the interactive or non-interactive mode. If you use the non-interactive mode or non-adaptive mode, then it will just say you, okay, you can run your batch of queries or not, because you have counted in the right way or not. In the interactive one, instead, it will have mini batches, and for each one of that, it will tell you if you can do these mini batches or not.
But I don't know till I run it whether
the batch of queries will satisfy the budget. No, that is.
I see. So I may run it and then find out that. Like,
No. Sorry, you can determine before running.
No, I mean, so, okay, I get that it's like always epsilon differentially private, but like I may start running the code and it may tell me like, sorry, I could not answer all the questions.
So the difference is this, maybe, let me try, is with Pink, you are running the analysis and you get this exception if you don't have enough budget. Here you are saying, I want to plan this set of queries. Tell me if I have enough budget or not. So it's before running.
Okay. And in particular, you commit to all your use of epsilon before you see the data.
So no, not it depends again. So it was extended to work adaptively based on the privacy filter approach, and there you can see the data before committing.
Okay.
All right. So let's see, where do we put this? So I put it here, meaning that I think is a bit less usable than the previous one, because now it requires some kind of annotation that we didn't need for pink, and a bit of reasoning about sensitivity, which is a kind of expertise. It is similarly expressive, because we can do more or less what we can do in pink. And the reason why I put it here is to give a bit the direction of granularity. Very bad idea, I agree, John.
Maybe like make the dot like bigger or something, like it's closer
Oh,
to
that's
us.
true, that's true. All right, so a bit closer to us in the sense that now we have this...
So it's the same expressiveness, but like...
At least you're describing like your own work as dominated by the previous work.
No. So, as I said, a bit less usable, similar expressivity, and the granularity is a bit, goes a bit more in granular.
Somehow in my mind, the expressivity, from what I understand, the expressivity of Irobot is like way less than what is expressible by pink or fuzz. Right? Irobot limits you to like statistical queries.
Yeah, I think you're right.
There's one thing you can do.
You're right. In some sense, also with pink, you can do only statistical query at the moment because you have only aggregation.
You can. Doesn't pink provide like an exponential mechanism type?
It's implemented by the Laplace mechanism.
No, but it's the report noisy max version, right?
Yeah.
So that's like a mathematically different use of the budget, right? You don't pay for the number of.
Right.
Right. You couldn't do that. That's the point. You couldn't do that in Irobot.
Yeah, I agree.
And in particular, you could implement like the static version, the offline version of multiplicative weights in pink, and you cannot do that in Irobot.
Yeah, I agree.
Like, just to pick an example.
Yeah, I agree. I will fix it.
Did you use pink for the MWEN? Pardon? Did you use pink for the MWEN?
No.
Why not? French was an author, right?
Yes, I don't
So-
know a good answer.
Also, I think the reality is that Pink was a working project in the sense that in the original Pink and the code that is still available online, there is no exponential mechanism. In the analysis I think they did for another project, they added the exponential mechanism, so it's not exactly clear. I think it's the problem of research software project. It was a bit an experiment. Okay. All right. So let me look a bit at the other problem. I think another issue here is that these that we saw are a kind of a general purpose approaches, but they are missing domain-specific tools. And I think when we want really to do some data analysis, maybe these are useful. People are trying to address this. I think one of the words that I like the most is the one by people at UMass and other, where they really try to build a language that is in principle like Pink in some sense, but where we have more of domain-specific primitives for dealing with data. So we can do bigger data analysis than what we could do, I think, with the basic Pink.
Sorry, so when you say there's sort of more domain-specific, you're like referring to the fact that there's all these like differentially private algorithms?
No, I'm referring, for instance, to the fact that it provides some construction like having vectorized object, trying to use a bit like a view of the data that is more specific. So I think the language permits only to do linear queries, at least in this implementation. So it focuses really on linear queries and how to do them well and scalable.
So, but again, like it sounds like this, you could in principle have just built this on top of Pink.
Yes.
So in that sense, it's like not a, right, it's not clear that it's doing something qualitatively, like you could think of it as purely syntactic sugar, right?
Yes, but I don't like this view because then everything is syntactic sugar.
No, I mean, there are things that, in terms of, you're talking about expressivity, right? In terms of sort of like the families of algorithms that could possibly be analyzed. Right. There are differences between these systems in terms of what they can handle.
Yeah. So these I didn't put on my picture, but these I would consider it less expressive, but we have a gain in terms of what we can do, in the way we can do things. In the usability and usability taking into account also accuracy and efficiency.
Maybe I'm sort of restating the question, but like somehow when I think of usability, I mean like, you know, there's lots of things that go into whether like I can personally use the language. I sort of think of usability as like, you know, how much work are you asking the programmer to do sort of on top of writing the code? Here, I think, maybe this was what I was point was is like, you know, if I have to write some of these functions myself, like to, you know, do useful transformations for like implementing some of these algorithms. That's like just sort of programming. That's just writing the code, right? Like I can either do it by hand, I can use this function, but it's not sort of asking me. It's not harder to use in the sense that like I'm not like having to get, say, like additional understanding of privacy or like additional.
Right.
I'm not having to say like supply. In tags on my code explaining to the type checker like why this should be.
No, but in some sense, so the usability is also So for me, is like, would you, as a programmer, if you use Pink, are you able to arrive to the same scalability and the same kind of analysis you can do with a software that has been designed to do that? In general, it requires you bigger effort.
Sure, but I guess what I'm saying, you know, if more people had like used Pink, maybe they would have just written some of these functions, and it would have ended up having like this exact set of like, you know, people like people use Python libraries, right? Yeah. Like in principle, I could write all that code myself. At some point, it didn't exist, but it doesn't make the language more expressive. It's just like, you know, it's somehow a different thing.
Yeah, I didn't say, sorry.
Python libraries are an interesting example because you mentioned efficiency. So, I mean, again, this is not meant as a comment against Ectolo in any way. It's just like conceptually what this is providing is, you know, arguably a subset of what Pink does, plus a bunch of functions that are provided in the, I guess, the language or the framework that allow one to, you know, that provide convenient pre-programmed ways of doing various things, right? In contrast, if I take a Python library like NumPy, like that is not just a bunch of Python functions. It's like super optimized C code that together with like a Python skin that allows me to call those functions, right? And so in terms of efficiency, it's like there's a huge difference between what I can do with NumPy and what I can do in native Python, in raw, like simple Python, right? Maybe not in terms of privacy or functionality, but like, so I guess that, you know, that seems like again, like another thing that one could imagine this could have done, but that's, from what you're saying, that's not what's here. It's not that these are like required, like new, as John was saying, like, or let's call it additions to the trusted code base. It didn't require more things that have to be analyzed carefully for privacy, for example.
I mean, my understanding, maybe Ryan is here, he can also correct me if I'm wrong, but my understanding is that these are trusted primitives that are added, and the key point is how to design this primitive. So I'm not claiming that this is more expressive than Pink. I think we all agree, since these deal with linear queries, that is less expressive. What it allows is to do like a bit, in some sense, optimize for this goal. Is like the primitive that it provides are the primitive that you would reasonably use to do this, to reach this goal. And these are not provided in Pink. You can try to implement them in Pink. You can add them to Pink. And in the end, yes, I think you would get something similar. But I think the main point is that when you add the primitive, you need to think about the primitive that you add. That is a programming language design.
Are these primitives in the language, or they're just like functions that are there that you can use? You can like, you know, you could rewrite yourself, right? Like it seems like again, there's like a qualitative difference between either things that are like in the built into the language, or again, things that require a trusted, like in order to, for example, prove privacy, you'd have to actually inspect their code as opposed, right? Like the difference between that, the where operator that Pink provides on the private database that you showed us.
Yeah.
Like there was a line in there that where there's like the stability of that operation is set to 1, and that's like an operation that you'd have to, like if you're going to argue that this is private, you have to like argue about that line of code. Right?
Yeah, I think all of these have that.
Okay.
Like this is where, for instance.
Right.
The exact example you took. So in some sense, I think is like maybe what confuses you is how I'm interpreting this. Is Pink give us a general picture of how to do the tracking of the privacy budget. Now, for me, we should not stop there, but we should also think about what kind of functionalities we want our language to provide. And I think what this language does is to go through what we would need to do linear queries in a good way.
Okay.
So, in some sense, what I'm trying to say is that generality is not always the goal. Maybe by restricting, you have something that is less general, but more useful in other direction. Now, the other problem is for this kind of Pink architecture is that it's difficult to formalize. People have tried to formalize part of it. Now, why do we want to formalize? Again, we want to make sure that it's correct. So, I'm yet not sure completely that the way Pink is implemented is correct. I'm not sure it does all the privacy budget accounting in the right way. Of course, again, I think it's a research project, Pink, so of course there might be some typos and so on. I don't want to make anybody accountable for that. It's just I'm saying when we want to design software that is correct, it would be good that we can formalize it. And with Pink, it's quite complex. Some people have tried. We will trying to use some formal methods to do this, but it's difficult to do. And finally, the other, for me, main issue that Pink has is that it doesn't provide any support for reasoning about privacy accuracy trade-off. And some other group have tried to address this. For instance, Gupta that was developed here provide a way to give information also about the accuracy of each analysis, and also the project at Harvard that Salil Badan has led focus very much on trying to provide information about the accuracy of each analysis, not only guarantee that they are private. And by the way, we will have more about all these different tools presented at the next workshop, so you can come back for it. All right, so in the next lecture, I will give you a feeling of how to go inside the black boxes, and then I will try to give you some pointer for the rest of the semester. Any other question? I think this is a good point where to stop.
Break for lunch. So remember, at 1:15 in this room, there'll be a discussion on DP and its use in the census, and then at 2, also in this room,